Hey everybody, I want to take a few minutes to talk about how to do the homework using the central called using the central limit theorem for section 7.3. It technically covers 7.4, although I do it completely differently than the book does. So let me bring up the homework. And so this is going to be not a like here are the answers kind of video. It's going to be just a few tips and tricks to let you figure out what the answers are. I will post the answers. By the way, I do have them. Let's see here. It's where is it? No, not that one. Oh, it's around here somewhere. Oh, I might have closed it actually. But I do have I do have the answers. It's very much like the answer sheets for the test or for the test review. So anyway, here is the worksheet. It's just 3 questions, sort of. I mean, it's like 30 questions or something, but there's only 3 larger questions. And I just want to give you a few tips on doing each one of them. The number 1 tip I will give you is ask yourself, do I need the central limit theorem in this situation or not? And the way you tell that is, are you taking a sample or are you asking about one thing? So for instance, I'll give you an example when we get down a little bit lower. Actually, I guess we'll use this one, right? So for each of these, we're going to decide if we're going to use the central limit theorem. If we answer yes, then check that it meets the requirements to do so. Remember that the requirements are you need a sample size of at least 30, or you need the underlying population to be normally distributed. And then once you've decided whether to use the central limit theorem or not, answer the questions. So I'll give you a tip. One of these, exactly one of these 9 questions, right? There's 3 parts with 3 parts in each one. Exactly one of them is impossible to do, or to find the sampling distribution. I'll leave it up to you to figure out which one. 8 of them you can do. 1 of them you cannot. For the one you can't do, what you should say is we can't do this, like for the following reasons. Yeah, so for each one of these, so I'll kind of talk my way through this one, and so you can see what you want to do on all of them. So TireCo produces a type of tire that has a normally distributed lifetime with a mean of 90,000 miles and a standard deviation of 5,000 miles. Now, one phrase should jump out at you, which is this, right? So this is telling me that the population is normally distributed, so that means we do, regardless of sample size, meet the requirements for the central limit theorem. So even though like Janine has bought one of TireCo's tires for her truck, so she's only buying 1 tire, so she's just using the population distribution, no central limit theorem needed. James, when he buys 4 of TireCo's tires for his SUV, you might say to yourself, aha, I caught you, Jeff. 4 is less than 30. I can't use the central limit theorem. But you're wrong. You can. Or you straw man are wrong. You totally can, because the population is normally distributed. And then 60, of course, and it's bigger than 30 here. You can definitely use it. So you want to do that with all of these. You want to pay close attention to if the population is normally distributed and then how big the sample size is to determine if you can use the central limit theorem. And you want to watch for, are you taking a sample or just looking at one thing, one wait time or 1 tire or one test, to determine if you want to use the central limit theorem. All right, that's it for number 1. Number 2, this is definitely the long one. This question actually used to have more parts. Oh, no, it still goes to O. This is my current record holder for most parts in a question. Up through O is pretty good. I'm feeling good about it. It's 15 parts. So same thing goes for the same thing goes here, as I said in the last question. So I noticed that the population here is exponentially distributed, not normally distributed. So watch out for that. And then you want to be looking for, so something like this, find the probability that a randomly selected phone call lasts between 2 and 6 minutes. That is not a sample bigger than 1. That is 1 phone call. No central limit theorem. Let X bar be the mean of 100 randomly selected phone calls. Well, that sounds like a sample. So watch out for that. Be really careful looking for those things where you use the central limit theorem versus where you don't. I don't love the way I wrote some of these questions in the following way. These ones, where is it? KLM, JKLM? Or no, IJK. So some of these are just word problem versions of previous ones that were just given as sort of math problems, right? Find the probability that a randomly selected phone call lasts between 2 and 6 minutes. Find the probability that the length of 100 randomly selected phone calls is between 2 and 6 minutes, right? And then explain why this probability is so much bigger than the one you saw before. And then there is, something in here. Where is it? 2 minutes or less. Shoot, I lost my place here. Well, anyway, here we're asking about how likely is it that Sophie gets an average call length of 2 minutes or less with 100 phone calls. One of the problems up here, there it is. Yeah, that's what I was looking for. Find the probability of the average length of 100 randomly selected phone calls is less than 2 minutes. You might notice that those are the same question. That's sort of my attempt, and this is a thing I would say if we were having class and doing this, which is where this started. That's sort of my attempt to give you two different perspectives on how a question can be asked, right? One can be just sort of straight math problem. That's it. And whereas this one, where was it? Gosh darn it. There it is, L. Whereas this one is more of a word problem. And the reason I did this was people often freeze up on word problems. They stop thinking about, you get a mental block in your head if you don't like word problems, or a lot of people do. And so I wanted to kind of ease people into the word problems. I don't know how well I did that, but that was the goal here. And so that's why those, like, if you're thinking to yourself, that seems awfully similar, I wonder what the difference is, there really isn't one. I'm gonna let you think about this one. I'm not going to comment on that at all. And this last one right here is the sum version. SUM, not SOME. The sum version of the central limit theorem. It's like the sumo problem on the notes, the very last one, right? We got to turn everything into totals, or it's given in totals, and you got to turn it into means, and then do the problem with the central limit theorem and put it all back in totals. Like that's how you want to do this. There's nothing too crazy here. Yeah, I'll leave it at that. So those are what you want to watch out for. If you have any other questions, come find me on Saturday. Office hours are, or excuse me, the discussion section is from 1 to 2. I think because I got the other videos up late because the encoding took so long, that I am going to hold an extra set of office hours on Friday. That sounds like it's probably a good idea. This is when I'm making this, it's Thursday, so I will go ahead and send you guys an email, and we'll do some stuff on Friday, probably in the afternoon, in case people want to ask questions. So I'll send out an email to that effect in a little bit. But there you go. There is my hint video for this homework. I will go ahead and leave you to work on that yourself. I will post the answers up, as well as my explanatory video for the answers, after the homework is due on Saturday. I'll put it up on Sunday. So what I really want you to do is I want you to have your best shot at doing the homework. I'm significantly more interested in you trying hard on the homework than I am in you getting the right answers on the homework. Right? Do your best to get the right answers, and I'll post the video about and the answers to the homework afterwards, so you can go look at it and see, oh, maybe I had a misunderstanding here. But the act of giving it your best shot will teach you a lot more than looking at what I did. Right? When you're learning, that's just how things work. It's very much like trying to work out, right? You're working out with a personal trainer. If the personal trainer lifts all the weights, you don't get any stronger. You got to lift the weights yourself. So anyway, I'm going to go ahead and stop this video now, and I will post up the answer video in a couple days. All right, see you in the next one.